Welcome to this first in a series of how-to videos on how to build a model of a fairground ride. My name's Pete Gaynord. I'm a generalist Key Stage 2 classroom teacher, and I've aimed these videos at fellow classroom teachers who would like to do this kind of DT in their school. And the idea is that if you watch these videos, you should then have you'll then have the know-how and the confidence for tackling this with a classroom full of children. This is the first ride we're going to look at, which is a classic kind of carousel type ride. I've not embellished it and decorated it, and if you watch these videos, you should then have you'll then have the know-how and the confidence for tackling this with a classroom full of children. This is the first ride we're going to look at, which is a classic kind of carousel type ride. I've not embellished it and decorated it in any way, shape or form. My model is purely to show you the construction principles. I've just put the ribbons on really so that the directional the direction of the rotation is more easy to see. But obviously the children will put rides on there, and I'll put casings on it and a bottom to it that would cover up the motor and all the workings. We'll do two videos on this ride. The first one will focus now on the DT and the construction of it, and the second one will focus on how to get the electronics and build in that kind of control technology part of the new computing curriculum, so you're doing something that's more cross-curricular. But as far as possible, the actual construction of it is very, very basic school DT cupboard components, as you can see. So the ride consists of a base with a motor driving a central column, and to complete this ride really all you need is this equipment that's on my table. You need your base, which is cardboard, a piece for the top which is cardboard, a couple of these kind of wooden wheels to attach to the spindle, one to lock it to the bottom which is not drilled, which fits the diameter of the dowling rod that we've got here. The other one's been pre-drilled so it fits the diameter of a thick art straw, and a pulley so we can stick a drive belt, which is just a rubber band. So we've got rubber bands here, and that pulley has also been pre-drilled so that it's the same diameter as the straw. The dowling rod, interestingly, is fixed. There's a central sort of spindle, and the straw is actually what rotates around the dowling. And then to build in the control technology, you'll need crocodile clips, obviously a glue gun and board useful for putting it together, although you can get it all by with PVA glue, but you just end up waiting for glue to dry, and that's quite time consuming. And then that's the little crumble control board that's actually driving my ride, because I've programmed this ride to do a sort of forward ride with one colour of LED blue flashing, and then a kind of backwards ride with a red LED flash pattern. And the great thing about this stuff is, unlike the old days of control technologies, now to program this little circuit board from Redfern Electronics, you just connect it with a standard USB cable to the back of your laptop, your school laptops, and you program it in a language that's very simple and very scratch-like. And I'm sure Key Stage 2 upper Key Stage 2 children would have no problem dealing with. To build up your confidence in getting going with the crumble, I recommend a website called Coded, which has all these little maker cards on it, which just explain the fundamentals of how to get going with the crumble controller. But the second video will deal more with the programming side. The first video is going to be a kind of step-by-step guide. Okay, so the first thing we need to do is to attach the spindle to this wooden wheel, and then glue that to the base. So plenty of glue on the base. Attach that to about the centre of the piece of card. Oh, by the way, the spindle can be any height at all, really, so I've left mine really big because the children might want to put like a canopy on it. So just make sure That's nice and straight. And then glue a cork down for the motor. We're going to attach the motor to this. Put that somewhere over there. So making sure there's going to be enough tension on the belt. So these are standard school DT motors, and these seem to work fine with this. To get the alignment perfect for the belt, we do that by gluing the pulley on last and making sure that the pulley lines up with the motor. So really important when you do it with children not to put any pressure on that motor as the glue sets by putting a band on it until the glue is really well set for the motor. But while that sets now, I can put the straw over my central spindle. This is what's actually going to rotate and spin. And I can put my pulley, which is a kind of snug fit because I've pre-drilled it, on the straw, and eventually I'm going to glue that. It's about the right height for the motor, but it's much easier to do that once your motor glue is set. So I'm going to leave that. We have to create something for the canopy that rotates to fix to, so I just put a little wooden disc there. I'll just glue that in place. Sadly, this is my last glue stick, so I'm going to try and squeeze every little drop out of this glue stick. We should remember to bring more. And then on top of that, I'm going to be gluing my canopy. Okay. And just try and make this as straight as you can. Just a couple of rubber bands have appeared down the bottom here. Probably an idea to put those there before you glue the top on, because otherwise it's quite a big stretch, get them over. And a little tip for fixing this pulley now is I haven't glued it at this stage because it's quite a nice snug fit. I'm just trying to get roughly the right height between the pulley on the spindle and the motor. And at this stage, this ride works with no crumble, no extra complicated stuff. And to be honest, I'm using the crumble battery pack, which is 3 1.5 volts AA batteries, so we've got 4.5 volts there. Now you just have to be careful. Some of the older school motors apparently run up 3 volts, but ours seem to be okay. I haven't burnt any out yet. And if that band's not coming off at that kind of speed, then that's usually a pretty good indication you've got your pulley in about the right place, and you can actually glue that now to the straw spindle. So we've now attached the pulley with some glue to the straw spindle. I know the motor's good, and I know it can be driven from a band. I've got my battery pack here, and I thought I'd just save myself the embarrassment of you watching me trying to get that glue onto that spindle with a pencil, trying to shove down the last 10mm of my glue stick into my glue gun. But anyway, things are all attached. That's the basic construction over now, and that's the kind of the mechanics of it, shall we say. So now over to the electronics and wiring those up. So we've got to connect the power for the motor. Now it is nice to use red and black if you can, and explain to children there is a convention for red wires being positive, but I don't have enough coloured crocodile clips at the moment. So I'm just going to take connections off my motor, off its terminals, and feed those into the crumble. So we'll have a green on that side, and we'll have a red on this side. There's a green and a red. We'll take that green and red now, it doesn't really matter which. And there's my crumble. And the crumble can drive 2 motors at the bottom, so I'm going to drive it off, let's go off motor 2, So I've got the green on the positive for motor 2 and the red. So those are the connections for the motor done. Then the sparkle. Here's the sparkle. The sparkle has to have power connections, and you can drive these sparkles without the battery pack, but you do need a battery pack in order to have enough power to drive a motor, because you can't get enough power out your USB connection from your laptop to drive the motor. So we connect the sparkle. We need 3 crocodile clips for sparkle. We need the 2 power connections. So there's a way in, there's kind of like an arrow on the sparkle. I don't know if you can see it, but it shows me I've got to put that. There's one of the connections, that's the first connection, and that goes to terminal D on the crumble. And then we need a positive and a negative. So there's a negative on the sparkle, and I'll collect that negative to the negative at the top of the crumble there. So connected the negative to the negative on the sparkle. Connect the positive terminal of the crumble, and you can daisy chain sparkle, so you can just connect the other side of this sparkle, it's positive and negative, to the next sparkle's positive and negative, and that's how you do chains of them. I'm just going to illustrate with one sparkle for this video. So we've got those connections there, and now really all we need is our battery connecting, our power pack. So I'm going to connect the black there to the negative and the red to the positive. So everything's got power now, but it's not working because it's waiting for us to connect this little lead that's connected to the USB port on the back of my laptop into the crumble, and actually to start now to program it in order to control that device of the motor and the sparkle. Now obviously eventually I'll stick the sparkle down on the base, but I'll just kind of leave it loose for now so that you can see the effects of our programming on it.